Hello, ladies and gentlemen. Welcome to this channel and welcome to this presentation. This is a long awaited presentation that I mentioned some time ago. So today we are going to look at boreholes and more specifically groundwater and see how things work and then what you must know. So it's basically what we are supposed to know about boreholes and all that. So whilst we go through this, I hope that you will learn a lot. You get to know more about groundwater and whatever we have or what our activities, though you may not have it in full, but the basic knowledge, I believe you have them, and then we can go with that. So, with this presentation, we're going to look at groundwater basically, and we'll look at how borehole works are done actually. Look at the advantages and, of course, the disadvantages of boreholes. We look at how we can manage groundwater. We will look at the challenges that we face and all that. So, globally, we have a total of about 35 cubic kilometer of water in total. That's the 100% water that we have globally. But out of this, over 97% of it is ocean water, which is saline, very, very saline, that is not potable for us as human beings. And then the remaining, which is about 3%, that is the fresh water available to the human race. And out of this, we have about 68% or almost 69%, which is ice caps and glaciers. And the remaining about 30% is groundwater. Now, for surface and atmospheric water, it contributes about 0.4%, and then permafrost contribute 0.8%. So from this, even at this stage, you can realize that groundwater is the largest freshwater available. Now, with the atmospheric water and then the surface water, we have about 67% of it being freshwater in lakes, and then we have about 12% being soil moisture. We have atmospheric moisture, which is about 9.5%. We have wetlands, which is about 8.5%. We have biosphere, that's water in human beings, in trees and plants and all that, which contributes about 1%. And the rivers, all the rivers that we have globally, contribute about 1.6% in all this. So from this, you realize that the largest fresh water available to mankind is groundwater. That is why we need not to joke with it. So you'd realize that in the upper picture we have an upper left corner, we have a picture there which has some hills and mountains and buildings and all that, and then you can see some streams, hillside streams, you have valley discharges and all that, so when it rains, what happens is that we call something catchment area is just an area where even if there's a drop of water that falls on the surface, they all collect and move towards one point and end up in a bigger channel, which are water bodies, larger water bodies, that such as rivers, streams, and the likes. And all these come together to end up in the larger water body, which is ocean or the sea. Now, when you look at the picture at the bottom right corner, you can also see that the surface is not that leveled, it is slanted, and it has some curvy nature on it, some dugouts sort of, or some uh, kind of holes or pits in it. And these are where we can have wetlands, we can have springs, we can have lakes, water bodies and all that. We have plants and all that. So normally the direction of flow takes the form of or the shape of the surface, but it is not always the case. It is not always the case. It can be the rivers, depending on the kind of geology. All this depends on the kind of geology that we have in that particular area. So the level that it takes, the level of flow subsurface may depict the topography, you know. So When it happens like this, what it means is that it may flow from a this thing, a higher an uphill or a higher upland or higher height to a lower distant level, and they sometimes they end up in streams, in wetlands, and all these things. So when we talk about groundwater, they occurs anywhere where there's space, space within the weathered zone or in rocks. Where there is space within the earth, water may end up there. That's what we call groundwater. And it is not like underground dam or something, but they are like, when you remember that I mentioned some time ago that let's take the egg structure as a foam, and you see some holes or a cushion, and you see some holes in those foams or cushion, and those are what we call those are where when you put in the water or you pour water on that foam, the water enter those spaces, and those spaces also get filled and they form the structure of the foam. But when we squeeze it, the water comes out, and you see that the foam shrinks as we squeeze it. That's what happens basically to with groundwater, and I mentioned it in our previous videos, you know. So those holes, when inside the earth or inside the soil, we call them pores. We call them pore spaces. And when we compare surface water to groundwater, when it rains basically, we have some of the water going subsurface that they infiltrate and then gets to a level where there's speculation. Now, the runoff is what we call surface water, which ends up in rivers, streams, dams, and all those water bodies. And those ones we all together we call them surface water. Now, when it comes to the rate of movement or the rate of flow, surface water run faster. They have they don't have much obstacles in their way. But when it comes to groundwater, because of the obstacle, that's the soil that is a blockade to it. They don't flow that fast as surface water. So that's what happens with surface water and groundwater. The rate of flow is very slow in groundwater, but very rapid in surface water. Now, as the tortoise thing we just saw previously, you realize that it takes days and months for the water to get subsurface, and sometimes going deeper to take years, and sometimes can take decades, and then centuries, and then sometimes millennia. So that is why we have a lot of groundwater. The earth holds a lot of water, that we can use. Yes, and so it is very important that we look at it. So those lines are lines of flow. So you see that they are the depiction, like I mentioned, they get when it's there's infiltration and percolation. Sometimes as a result of capillary rise, they may end up in a large water body, as we can see from here. So you can see the discharge area, the recharge area where the water gets into the soil, and the discharge area which is the stream, the water body where you can see the arrow pointing to. That's a river or some channel which we can call a river or something, a water body, you know. So when you drill a borehole, they enter into certain areas, and then for it to tap the water from subsurface. And these areas is called what we call aquifers. When we mentioned aquifer in our previous video, I explained this thing that aquifers are rock bearing, water bearing rocks. They rocks or soil that hold water. Those are aquifers that we mentioned. And these aquifers, as I mentioned, they can be found in the soil or in rock structures, where a rock that have some structures, that's some cracks or spaces in them, and or that is what we call structures, or they have fractures, dikes, and all that. That's where we find these aquifers, and we have different types of aquifers. We have confined, unconfined, and semi-confined aquifers. And when we talk about unconfined aquifers, it means that there's when we talk about confinement, it means that there's something that is prohibiting, or that is a blockade that the water cannot move or cannot flow through. There are impermeable material that prevent the movement of water. So if the aquifer is unconfined, means that there's no barrier or this material that can prohibit the movement of water is not available. So um, the water just flow underground.